Hey kids, Mr. Little again. Hard to believe, but it is week 7, and we're going to go through different aspects of life science. One of the items that we feel you are going to need, or at least have a pretty good comprehension of, is how to use the microscope when you are in high school. You do a significant amount of work with the microscope in 7th grade, but we don't really get to use it too much in 6th and 8th grade, so look at this as more of a refresher than anything else. Okay, so I'm going to go through each of these key items here. These labels up at the top are the different components of this microscope tutorial. So in this activity, you will identify the different parts of the microscope, learn how to locate and focus on an object or a specimen in the microscope, adjust the optics to obtain a clear image of the specimen, and finally observe the details of a specimen under high power. Okay, so we're going to skip right ahead to the overview. And you can see here, it's got a number of graphical images over here, and it says roll over the different parts of the microscope to identify them. So if I look at each of these, there's a bunch of things that come up here. And I'm going to go ahead and see if I can make this a little bit smaller. That way we can get everything in. Okay, so if I look at the top part here, we'll start here. These are called the binocular eyepieces. Your microscope may have a monocular eyepiece instead, meaning it may have one eyepiece instead of two. Obviously, this is the area that you're going to use to look through into your microscope. Okay, traveling on down, you can see here the next part. The objectives, they contain the different lenses. Most models have 3 different objectives, kind of a low power, mid power, and a high power, if you will. So by turning these items, you will be able to see different magnifications of the specimen or the object that you are looking at. Okay, next item down here is what's called the stage or the platform on which you place your slides. So when you have a slide, usually it'll have a couple pieces that you tuck it into, and it rests on top of the stage quite securely. And you may have to manipulate that just a little bit to make sure that it is in focus through the eyepieces. Okay, traveling on down, we have the condenser diaphragm. The condenser diaphragm controls the contrast, in other words, how dark or light the image appears. The dial in the edge of the diaphragm is used to regulate the openings of the aperture through which the light passes, thus making the view appear brighter with less contrast or dimmer with greater contrast. Some microscopes also have a stage diaphragm, but this one does not. The condenser diaphragm is pretty important when you're looking at the thickness of different specimens. Specimens or objects that are very thin or very thinly sliced, you would definitely have you would control the contrast to make it a little bit darker. Whereas if it's thicker, you're going to want more light passing through, and that's where you would use that. Okay, here's the buttons, the fine focus controls. It fine-tunes the focus, so it kind of controls it in the vertical, the up or down of the microscope. It's really important, though, that when you are using or manipulating this item here, that you don't push these far enough down where it contacts the slides. If you push these things down far enough where it contacts the slides on the stage, it may actually break the slide, so you have to be really careful with that. Okay, at the bottom here you've got your light source, the actual source of the light. This is where your bulb is in place, if you will, to help focus the light. And I don't think there's anything else on any of these other images that I need to discuss. Does not appear up. There's one down here, a dimmer switch. Didn't see that on the other one. And it turns on and off the light source and controls its intensity. In other words, it's almost like a power switch, if you will. And that may be located on the left, right side, or even the back side of a typical microscope. Okay, so moving on to the next content area, setup. The first step helps familiarize you with the microscope and set some preliminary adjustments that will make the lab run more smoothly. So you will follow these instructions when you are, let's try that again. There we go. Okay. So the necessary steps would be obviously to turn on the light source. Remember, that's this guy right here. That's going to turn on your light source. Take some time to play with the condenser diaphragm, which is right up here. Dial to see how it regulates the light. Notice that turning the dial changes the brightness of your view, but more accurately, the condenser diaphragm is adjusting the aperture of the light path and thus changing the contrast of your view. In other words, brighter is less contrast, dimmer is more contrast. Number 3, make sure your microscope is set to the lowest power objective. You will see up here, and this image doesn't show it here, but on each of the 3 different power adjusters, I believe it's typically yellow, the yellow one that is your lowest power, but I could be mistaken. You'll have to check the particular microscope with that. Okay, next one, looking at the microscope from the side, position the stage and objectives close together using the coarse adjustment, which is this wheel back here. This is your coarse adjustment wheel. Again, make sure that when you are adjusting these that you don't make contact with the slide itself, because that will break the slide. And finally, number 5, make sure the condenser is close to the stage. If necessary, use the condenser control, the small knob on the left of the microscope, to move the condenser closer to the stage. Typically, you won't have to adjust this unless you move it by mistake, which is easy to do if you don't pay attention. Remember, things to remember for 2 students working together on one scope. Place the scope between the 2 of you. As you take turns looking at the specimen, swivel the eyepiece. Don't shift the scope back and forth between the 2 of you. Keep the microscope upright. This is especially important if there is any liquid on the slide, since tilting the microscope can cause the liquid to drop off. And finally, talking about swiveling the eyepiece on many classroom microscopes, you can swivel the eyepiece to share the view with your lab partner without having to readjust framing or focus. Okay, mounting the slide. If you have a binocular scope, such as this diagram right here, adjust the width of the eyepiece until you see one circle of light in the field of view. Put your slide on the stage and move it around until you can tell there's something interesting in the field of view. Remember that images are inverted, so if you physically move the slide away from you, the specimen will appear to move towards you. Hold the slide firmly and clamp it into place. You can still adjust the position of the slide after it's clamped, but typically you should find the best placement you can before clamping. Next up is focusing. Follow these steps. Check that there's some play in the fine focus. That is, the fine focus knob is towards the middle of its ranged motion. This will ensure that you will be able to adjust the focus once you go to a higher power objective, since you won't be able to use the coarse focus at that point. Remember, it's the coarse focus knob that has the potential of contacting the slide, and that is a big no-no. Now, use the coarse focus adjustment to get the sample into focus. Often the coarse adjustment is enough for focusing at 4x or 10x magnification, but you can use the fine focus to sharpen the image. 3. Use the diaphragm dial to adjust the brightness of your view. Remember that this controls the aperture and hence the contrast of your view. A wide open aperture is too bright with too little contrast, so you'll lose detail. Narrowing the aperture reduces the illumination and makes the specimen stand out more from the background. Number 4. Work with both the diaphragm dial and the coarse focus until you have a crisp and detailed view of the image. You can also use the fine focus if necessary to finish off the focus at this point. Okay, moving on to low magnification. Change to the 10x objective to increase the magnification. Note that when you go to a higher magnification, the view will appear more dim. Use the diaphragm dial to decrease the contrast, thus brightening the view, and the focus controls to refocus. Remember that most microscopes, at least in high school labs, are parfocal, which means that if one objective is in focus, they are all in focus. It's very important to remember that once you go to any objective higher than 10x, the coarse focus adjustment is not used. This can move the stage too close to the slide, and it can break the slide or worse, scratch the lens. At high magnification, and in this case it looks like the 10x is the yellow one, which I think earlier on I said that the 10x might, or the yellow knob might have been the lowest power, so that may be incorrect there. But at any rate, change the objective to 40x. This magnification is called high dry, since at this magnification there's still enough light to view the slide directly. With the 100x objective, there is too little light to view the specimen directly, so it requires a drop of oil to enhance the illumination. The illumination gets even dimmer now. Use the diaphragm dial to decrease the contrast, brightening your view, and the fine focus to refocus. At higher magnifications, the depth of field gets very narrow, so you may not be able to focus on the entire image at once. Play with the focus a little bit and notice how certain details fall into and out of focus as others do the reverse. At higher magnifications, you have a smaller field of view, so you're now seeing a more limited portion of the specimen. Also, remember that the specimen on your slide has a thickness, even though it looks very thin. As you adjust the focus, you're actually focusing on different layers of the specimen, an effect exaggerated at higher magnifications. Think of the specimen as being as thick as your classroom. Then you could be focusing variously on the ceiling, and the desktops, or the floor. The depth of field is the portion currently in focus. And lastly, a couple things to remember. Don't leave the light on the microscope for too long. This not only wastes energy, but it is especially important for live specimens since it can dry out the specimen and whatever it is you are looking at may potentially die. For living specimens, leave the light on for no more than a few minutes at a time. You can always turn off the light, wait a while, and then go back to viewing the slide. And finally, remember to turn off the light when you are finished. Leaving the light on for long periods of time wastes energy and can harm the microscope by overheating. Okay, kids, this concludes our microscope tutorial for week 7.